All right, thank you, Maxime, and thank you very much for the invitation to be here. It's very exciting to be here. I'm pretty new to the eResearch space in New Zealand, so it's been really fun just already learning yesterday and today a little bit more about what the community is like, and of course, meeting all of the people. Let's see, I can't actually see my slides. Maybe I'll use my computer. Nope. So yeah, I'll be talking today about research, software as research infrastructure. And just go ahead and dive in. Oh, there we go. So my talk structure, just so you have a sense of where I'm headed, because I'm going to try and cover a few different topics. I'll set the scene initially. What is ACCESS-NRI and where do we fit into the landscape? And then I'll talk a bit more generally about kind of my thoughts of software as research infrastructure. And then I'll share some of our learnings from the ACCESS-NRI journey so far. So throughout this talk, I'll be sharing some of the kind of structures of how we've set up ACCESS-NRI as a facility for software as research infrastructure, and some of the learnings that we've had from that. My goal is actually to spark some ideas and discussions, and I'll be here all week and would really like to meet many of you and have more discussions. So I'll start with what is ACCESS-NRI. ACCESS-NRI is a very long acronym. This is why we call ourselves Australia's ClimateSimulator. But the acronym is actually descriptive. So the ACCESS stands for the Australian Community Climate and Earth System Simulator, which is our collection of Australian climate models. The NRI stands for National Research Infrastructure, and that is a nod to our funding, which is federal funding as research infrastructure. And I'll talk about more at that in a moment. We are federally funded, but we are housed at the Australian National University in Canberra, Australia, although our staff does sit remotely across Australia. So in a nutshell, ACCESS-NRI is the ACCESS climate model software and the specialist team that develops and maintains it and supports the research community to use it. So our funding, I mentioned we're federally funded. We're funded through the Australian government's Department of Education, which has the National Collaborative Research Infrastructure Strategy, or NCRIS. So NCRIS funds most of the research software that we might think of, HPC centers, linear accelerators, that kind of thing. It also has funded us, ACCESS-NRI. We started in 2022, so we're still pretty young. And we are the first NCRIS project who was funded primarily around software, not physical infrastructure or similar. Now, I put a star on this, there's a little asterisk, because we are not the first to do a lot of software, and we are actually not the first that is primarily software-based. But we were the first that put in a proposal to say we think software deserves to be supported as infrastructure, and that we got that funding, which I think is pretty cool. So this is one of my favorite visualizations that we have of one of our models. This is one of our ocean models, and you're seeing the ocean currents here. It's from one of our higher resolution ones. Our models are really, really big. They're very big, they're very complex, and there are many of them. We have different models for each component of the climate system. So this is the ocean, we have the atmosphere, we have the land, we have sea ice, we have ocean biogeochemistry and all of the different processes. And overall, we have over 3.9 million lines of code. So these are really, really large in scale. And they're so big, we have to run everything on an HPC, not just running the model, but we also have to do all of our data analysis on the HPC. We can't just copy things over to our laptop. We have to do everything on HPC. So, little shout out to our HPC. We really rely on them to exist. So though we are software as infrastructure, we do rely very heavily on the physical infrastructure. And to give you a sense of the numbers, that ocean model that I just showed you, for a 100-year simulation, it takes 12,000 cores, 1 month of wall time, and 40 terabytes of data output. And that's just one model simulation at one particular resolution. we're running lots of these all the time. So we are very, very heavy users of HPC, specifically the National Computational Infrastructure, or NCI, which is one of the Tier 1 HPCs in Australia, also funded by NCRIS. So we're not just dealing with really, really big code. We're actually dealing with kind of a large magnitude collaboration as well, and coordination across different entities. So we work with an array of partners. These are different universities and government organizations in Australia. And there are a lot of other national and international collaborators, only some of which I could fit here. You'll notice that there's the Met Office in the UK, there's GFDL in the US, and there are several others. Many of the code bases for the models that we use are developed in different countries. And so this becomes quite a coordination effort. And we have over 170 GitHub repositories in our ACCESS-NRI organization, and over 1,250 contributors. So this is kind of massive in scale in many different ways. All right, so I said ACCESS-NRI is pretty young. So I'm saying this, we're helping to coordinate kind of this massive scale of climate modeling. But where do we fit into this, this picture? What was happening before we existed? So I'm going to take you through one of my schematics. I really like to visualize things, but I also have no artistic talent, so I apologize. You're just stuck with my emoji-centered schematics. But I'm going to walk you through a journey in time. So we're going to go back a few decades. This is very specific to the climate modeling research space, where the research tasks involved kind of encompassed everything. The models were small enough that the researchers were writing the models, they were running them on their own workstations, they were writing, finding the scientific insights and publishing the papers, they were kind of doing it all. A couple decades later, it started to become clear that the models were getting large enough that really benefited to have this centralized computing space alongside other research fields, of course. And so we kind of pulled out the compute so that the researchers didn't have to worry about that, and they got access to much larger compute and to a specialist team of the people, the HPC specialists. What we're seeing now, so fast forward to now or a few years ago, we're seeing something similar with the software. The software is becoming big enough and complex enough that it makes sense to centralize it, to extract some of that software tasks from the researchers so that they can focus on their research, they can focus on the science, and we can have this centralized software and develop the specialized expertise to really do better with this kind of software. Lost my train of thought there. I'm actually going to amend the bottom of this diagram specifically for ACCESS-NRI, where we are extracting out the software from the researchers, but we're trying not to take it away. We're not trying to take anything away from the researchers, but to give them the flexibility that they've always had, but to help them with the technical back end. So I amended this here to say we actually are really integrated with the research community. That's one of our main goals. I'll talk more about that later. And the researchers are actually still very actively involved in the software. We're just trying to help with those real software engineering tasks, which have become really required in order to run our climate models. So this is where ACCESS-NRI sits in the landscape. Hopefully that diagram was somewhat helpful. So much like we saw the centralization of compute with HPC, now we consider that part of the infrastructure for research communities. We can consider software to be the same. It can be treated as infrastructure. But it isn't necessarily always, not all software is infrastructure. If you have a 10-line Python script, that probably shouldn't be infrastructure. They're all blurry lines, but that one's probably pretty clear. So I next wanted to walk through when does it make sense, when is it helpful to think of software as infrastructure? So if it's big, if it has significant complexity and scale, which we certainly have with the climate models, if the skill set is sufficiently different from research, I think that's an important one. This has definitely become the case with our climate models, where we're finding that researchers are needing to kind of moonlight as software engineers to be able to actually develop and build these models. If they require long-term investment, we definitely want our models to have long-term investment so the scientists can continue doing their science for many years. and if it benefits the broad research community. So I think our climate modeling software certainly fits these categories. Many of us are probably infrastructure people here, and you're saying, well, this is just every infrastructure fits these categories, which is true. So how is software different from the physical infrastructure? I'm going to start with the fact that it's not capacity limited. So what I mean by that, if we think of physical infrastructure, I'm going to use HPC as my main example of that. It is a finite resource. So you end up putting a lot of effort into the scheduling to make sure that all the community members have access to it. That's not the case with software, or it doesn't have to be. We can theoretically scale the software really well, where we can have many different researchers using it all at the same time, running our models all at the same time, and it's never used up. So I think that's a kind of interesting difference. Software continuously evolves, at least more so than many of the physical infrastructure that we might be aware of. So our physical infrastructure tends to have these periodic upgrades every few years. Software tends to be much more iterative. So we're fixing bugs, we are adding new science, and it happens in a much quicker scale. And so that means that in addition to our ongoing maintenance to make sure it continues to run, we have to make sure that there's ongoing engineering that's happening all the time. Users are also the contributors. That's very much the case for ACCESS-NRI, as I mentioned, where we really have our scientists are domain experts who are helping to contribute. And I think that's something that really sets us apart, where we really need that integration with the community. And the last thing I'll mention is that our funding is actually a little bit different. We don't have any capital expenditure because we're not buying anything physical. So our budget, 87% of our budget goes towards salaries, which I think is really interesting. So most of our budget is going to support our staff. All right, so that's kind of the general discussion. Let's dive into some specifics. Where I'll discuss a few learnings from our ACCESS-NRI journey so far. Definitely so far, because we still feel like we're on this journey. And I'm going to start by talking about some of the collaboration with the research community. And I'm going to tie some of these into our ACCESS-NRI values, which we do highlight. So the first value that I'll mention is that our priorities are determined by access community needs in addition to national interest. This one is very important to us. Our community comes first, and that's where we want to get their involvement. And to do that, by the nature of kind of being a centralized entity, even though we're trying to stay integrated, we've made sure that there are formal structures set up so that we can keep getting input and feedback from the community. So the first thing I'll mention is probably our most formal structure, which is the Scientific Advisory Committee. As it sounds, this gives the scientific guidance and advice so that we can prioritize our time and efforts. And I'm going to highlight a specific challenge on this one that we've had. So this committee was established when ACCESS-NRI was formed in 2022. And we had members from each of our partner organizations on this committee. And those individuals are really fantastic and have been really wonderful. But we found that the group setting just wasn't quite what we were hoping for. We really wanted more interaction, more dialogue, and we were finding it was very one-way, where we would present our plan, and we didn't get a lot of feedback. And so we've decided to revamp our committee. So now we're seeking self-nominations. So we want people who are actively interested in taking part. And we are focusing on the scientific domains, because that's actually what this committee is about, not on representing each of our partners. Don't worry, our partners are all represented on our board, so they have a governing role. And these self-nominations are currently open at the moment. So this is a very current revamp, and we'll see how this goes. Check back in a few years. But hopefully that'll get us more input that we're looking for. We also run community working groups. These are kind of run by the community themselves, but we're trying to support that. And this, by different community working groups, we have them for different components. We have the atmosphere working group, ocean, land, machine learning. And many of these communities already had kind of cohesive communities before we came on the scene, and some didn't. And so we're really trying to encourage each of the pockets of our community to form these groups, to meet regularly, to have these discussions, because we think it really benefits the research community themselves. But of course, it also benefits us. If we have a unified voice from the community, that's helpful for us to make sure that we're addressing all the community desires. I think this has been quite a success. One very specific example is around selecting our ice sheet model for the ACCESS models. Previously, there was no ice sheet model incorporated in our broader ACCESS model framework. But the cryosphere working group really took the lead and said, yep, we're going to choose this as a community. And they led an open discussion. They met over several weeks and months, did some research about all the different models that exist around the globe. And they ended up choosing a model after all of these discussions. And most of the community is really backing that model and adopting it. And I think that's one of the real powers of having this be very community-led. It would have been much faster and easier if ACCESS-NRI just said, we're just going to choose one. But we were like, that's really not our goal. I actually think going back to our keynote from this morning, it was mentioned that if you're really human-centered, then it's more time-intensive. I feel like we're feeling some of that as well in what we're doing. But we really think it's worth it. I think the adoption from the community has made that clear. All right, so the next value I'll bring in is this openness and transparency. So everything that we create has an open source license. We develop in an open and transparent way, mostly on GitHub. I do have to add a caveat that one of the models that we use is not open source, so that is a bit of trickiness. But everything that we kind of create, anything that's possible to, we make an open license. And part of that openness and transparency is that we're trying to bring the community together to have open discussions. So we created this online discourse forum, the Access forum is what we call it, so that there can be asynchronous discussions throughout the community. And I'm going to highlight, I actually think overall the forum's been pretty successful. But one of the challenges that we've had is our user support scheme. So we run our user support scheme on this public forum. It's a Stack Overflow style model where the community can post a question and then anyone can respond, because ACCESS-NRI certainly doesn't always have the answers, in fact, rarely. And anyone can see the responses, which really benefits everyone. I'd say this model is working okay, but we aren't getting the volume of requests that we expect and that we kind of know are out there. And talking with the community, we think this fear of judgment on a public platform is probably the main reason. So I think our good ideas were more in theory than practice. But we are offering a new private help option, which is pretty recent, hasn't had a lot of uptake yet, but we're kind of still trying to figure out how to best support the community and balance these different things. The last collaboration thing I'll mention is that it's not all about these specific structures that we've set up. We're really trying to encourage this organic community integration. So encouraging these more informal interactions to kind of get more camaraderie in our community between researchers and our staff. I'm classifying this one a bit as a success and a challenge. We've had some real examples of community members who are attending our meetings and who come into our offices. And the same thing where many of our staff will go to local universities where they're located and sit with some of the researchers. But I think we were hoping that there'd be a bit more of this. But this comes into a little bit of kind of community management style things where we're trying, it's weird to kind of encourage informal interactions. So I think this is one we'll just kind of keep monitoring over time and see if we can kind of encourage this a bit more. All right, so now I'll talk about the specialist career path. So I think that's a really important part of ACCESS-NRI. Almost all staff at ACCESS-NRI are research software engineers by title, almost all of us. And just so we're on the same page, I actually had a really interesting discussion with some people yesterday about this title. This is how I see research software engineer. It's a spectrum where at one end you have research, people with research backgrounds who are interested in the technical side, At the other side, you have people with a software background, computer science, who are interested in applying those skills to research. And anyone along this spectrum at any point can be considered a research software engineer. And I think ACCESS-NRI, we really do have this full spectrum backgrounds. So ACCESS-NRI really wants to support the staff. That's one of the values. We invest in the skills and capability of our workforce. So we're not just trying to fill roles, we're trying to help build a career for our staff. And the example I'll use for this is a specialist promotion stream. This is where staff can be promoted based on their technical specialist expertise, not just on being a manager, which is what the traditional structures were. For many of us, this may sound really obvious, but this took over 2 years to push through at our university, and it existed before. It just took 2 years for us to get it at our institute. And part of that was we didn't do it for any individual. It wasn't just a few people we wanted to promote. We wanted to make sure that it was a stream that all of our staff had available. And I think that's a real credit to our director who continued to push this. And now we have that. So all of our staff are on the specialist stream and can be promoted for their specialist expertise, which I think is pretty cool. But we're not just supporting our staff. We're interested in training the next generation of research software engineers. So helping this career path in general. So the same value, we invest in the skills and capability, not just of our workforce, but of the wider community. And the example I'll share with this one is our ACCESS-NRI PhD internship program. This is actually a program I'm running, and it allows PhD students from select Australian universities at the moment 3 months as a research software engineer with us. And our goal for this program is that the interns gain relevant skills and experience. It's not about how much contributions they make to our models or anything like that. Our goal is really for them to experience what it's like and to gain some of those skills. We actually did run a trial program last year with 4 interns, and it was quite successful. So we're pretty excited about that, and we're planning to launch our full program later this month. All right, so I've talked about the idea of software as research infrastructure. But if we think back in my talk, a lot of what I've mentioned, the underlying theme is kind of that it's all about the people. So maybe I should have called this talk, People Are the Research Infrastructure. I think there's no better example than this, go quickly here. We have an Earth system model that we are about to release called ESM 1.6. I think this is a great example of how it's all the people who are coming together to make our models happen. So I'll just quickly step through. These are all the different components of our climate system that are in the model, and each of these has a community, a research community that we are working with. So we're working with the atmosphere community, with the land community, with the ocean community, with all of the rest of the communities, and they're coming from different universities, government agencies, partner organizations, even within ACCESS-NRI, it's touching almost all of our teams, only some of which I mentioned there. And of course, we're working very closely with NCI and all the specialists there, the people there. We really rely on that HPC expertise and on the data expertise to make sure our data is well stored and maintained. All right, so I'm going to end here and say that we are very much still on this journey. In fact, at ACCESS-NRI, we feel like we're just starting to find our footing. But I know that this is a pathway that many of you in this room probably have helped shape. So this is very much a shared journey that I think we're all on in the eResearch community and trying to support the software. So let's all learn together as we build these structures to make sure that we're supporting the software and the people and their careers that make it happen. Because it's through this kind of collective effort is how we're going to make sure that we can continue to enable our research communities for many decades to come. So I'll end it there. There are some links if you're interested. And yeah, thank you.
Thank you, Paige. We have time for a few questions, if anyone has one. Yes?
Well, thanks, Paige. A really nice presentation. Can you tell us a little bit what the ratio between RSEs and scientists is in that organization? And what you regard as being maybe
Yes, good question. We are entirely RSEs. There are no scientists. We don't do science. We don't do the research. So we're pretty kind of clear on that. So I guess that's the short answer. But that's why we're trying to work so closely with the researchers. And many of us do come from the science research background. But yet we're all RSEs. The only science I know that's going on is on the side. Yeah, I don't know.
The researchers that you come in to do internships, the PhD program that you kind of commented on, you said it was quite successful. How are you, like, what do you determine success there? What does success look like?
That's a very good question.
Yeah, and I assume they're researchers. The PhD students aren't. Yeah.
That's right.
I assume they're solidly scientists.
They are solidly scientists, yes. So that is a case where we're really specifically trying to expose the research software engineer career to researchers, to early career researchers. And yeah, it's a good question. Most of the reason why I said it was quite successful is from the feedback from both the interns and all the staff that helped with the mentoring. It was just like overwhelmingly positive, to be honest, which was really great. Maybe everyone was just really excited. Hopefully that continues. But I think it was really valuable, and we did get a lot of feedback from our interns who said it was really nice. I like that they felt individually supported, and it really wasn't about their output. That was specifically raised, so that's why we're really continuing to kind of promote that. But yeah, really based on that feedback.
Thanks. Just being conscious of time and that teleportation does not exist.
I was going to say, I do have a song that I could sing, because I didn't know this was a thing. I didn't know this was a thing, I have to say. I'm pretty new to the New Zealand culture, I admit, but I was just astonished this morning. And I hear that, yes, sometimes there's a song. This will be a very different song than this morning, but it is related to modeling. Is that okay?
Make time for this.
Okay, I'm only going to do the first verse, so it's very short. I run a modern model of the ocean and the atmosphere. Well, technically, it's only of the ocean and the troposphere. It's quasi-geostrophic, and it isn't even seasonal, but we as ocean modelers think this is all quite reasonable. A model maker needs a mix of math and ingenuity, and intuition's needed to remove some incongruities, but when your model runtime is so close to perpetuity, it gives you all the time you need so you can go and brew a tea. Thank you. I'll leave now.
Thank you again.
Thank you.